This tutorial we will further write some more simple programs to understand the working of those registers that we had in previous tutorials A, B, C, D, E and HL. Today we will do some small calculations. So the program that you can see that I have typed is almost similar to the program that we had in tutorial number 2, but there is an extra command mov b comma d. So let us first save this program by going into the file menu, save as, then giving it a name program2.asm and browsing it to the required path. Then just save this program. After saving this program, before executing, let us understand that what will this program do. So we are already aware that this first command mvid05h will move 05 into D register, then mov b comma d. Now in this first command you can see that immediate data, which is represented by this I, immediate data 05h is moved to the register D. Now in this case we are moving data from one register to another register. That is, move b comma d command will move the data from the register D to the register B. Remember that the direction of movement of data is not forward. It is not from B to D, it is from D to B. So that is, the data will be moved in the reverse direction. So whatever is kept inside D will be moved to the register B after the execution of this command move b comma d. So this is the new thing that we are going to learn in this tutorial, and halt is for making the computer stop its operation. So earlier we have seen that to run a program we need to go to the assembler and then execute it once for all, but in today's tutorial we will see that how can we step by step execute this program and how can we see the changes that are made by every command in this step by step. So for that you need to go to this debug menu and then step in, or you can also do F5. Every time you will press F5, one command out of these will get executed. So we will press F5 and we will get started with this program. So I have pressed F5 for the first time, and you can see that we have moved on to this first location. So now if I will press F5 again, this first command will be executed. When this blue marker appears here, it means that we have reached to that location, means the next instruction which is to be executed is this. So once I have pressed F5, the program is started, and again if I will press F5, this command will be executed. So after the execution of this command, inside the D register, that is inside this value, you should see 05. So let us press F5 again and execute this. So we have executed this, and you can see that a value of 05 has been moved to this D register, which is shown here. Now we are on to the next location, which is called as move b comma d. After the execution of this command, the data from this D register, which happens to be 05, it will be moved to this B register. So here also there should be 05 written. So I press F5 again, and you can see that the corresponding changes are reflected here also, and then halt the computer. If I will press F5, the complete program has been executed. Now what is new with this command? This command is moving data from one register to another register. So you can use any registers here. It's not compulsory to write B and D here. You can use any of these A, B, C, D, E and HL. So data from anywhere can be transferred to anywhere. This is the use of this command. Now let us reset all of the registers and write another program. And this another program I have already typed it. So this program is again very simple. You can see here that first of all I have moved the immediate data into A register, which happens to be 05, moved immediate data into B register, which happens to be 06, and then I have written add B. Now when you add something, it has to be at least two numbers, but here you can see that I have written only add B. So now, as I have earlier said, that accumulator is the default register and the results of calculation will be stored into the accumulator register. So here when I write add B, I mean to say that this addition should take place with B and the contents of the accumulator. Whatever will be the contents of accumulator, and B will be added to it, and the result of that calculation will be stored in accumulator register after the execution of this command. So this is the meaning of this thing. So you can see that since we have moved accumulator with a data of 05. There is a data of 05 in accumulator after the execution of this command, and inside B there is a data of 06H. So when you will execute this command add B, so this 6 will be added to 5, it will become 11, but 11 will be in decimal, so the hexadecimal equivalent of 11 will be stored in this A register after this calculation of add B. So let us execute this program step by step. So mvi a comma 05h, press F5, so 05 is moved here, then again press F5, this command will be executed, so F5 is pressed and 06 is moved into this B register, C register is vacant, and then you press F5 again, add B will be executed, 06 and 05 will be added, and the result will be stored in A. So if I press F5, 0B is stored here, which happens to be the equivalent of 11 in hexadecimal, and HLT is used for halting the computer. So this is all about how to make calculations and how is accumulator performing as a default register in 8085 processor. Now we can also do a similar operation for subtraction. So let us see the program for that. So mvi a07h, mvi b02h. Subtraction has a command sub b. Now the default meaning of this is whatever are the contents of B, they will be subtracted from H, and the result will be stored in A again, because whatever is the content of B will be subtracted from the accumulator or the A register, and the results of this execution will be stored in A again. So I will execute it once for all, and you can see that 7 minus 2 will be 5, and 5 is stored in accumulator. So you can see the step-by-step execution of this by yourself. And now let us see another way of subtracting numbers. mvi a07h, I have reset all the registers before executing this program, and instead of sub I type sui, and then I have written 05h. This I always stands for immediate data. So this immediate data of 05h will be subtracted from this accumulator, and the result will be stored in accumulator again after the execution of this program. So I will execute it once for all, and you can see that the result of 2 is stored here, and no other registers are changed out of A, B, C, D, E, and HL, because we are interested in these registers only as a beginner. So you can say that see that subtraction can also be done in this mode. Similarly, for doing addition in this mode, there is a command of ADI, add the immediate data to the accumulator and store the results in the accumulator. So you can do that also by yourself. So this is all about getting introduced to very simple operations and the role of accumulator in 8085 programming. We will see more tutorials and more sophisticated programs. So keep watching our channel and subscribe to our channel.